So let's be direct. Kubernetes is filled with indirection. It is so confusing. It's rife with indirection and things that there's volumes, there's volume mounts, persistent volume claims versus persistent volumes versus volume attachments versus storage classes. And I haven't even started talking about the CSI drivers. So there's a lot of indirection. We're going to explore this, and we're going to understand why they exist and what the problem they're solving. So problem number one, let's just talk about storage problems and how they're addressed in Kubernetes. All right. Problem number one, for some reason, I need to access data that's stored on the host machine. We saw how to do that with Docker, Docker-v, target source, target :source. But how would I may want to do the same thing in Kubernetes. And here we see the first bits of indirection. What I'm seeing here is a Kubernetes pod that specifies what I just described. So what it's saying is the pod wants a volume mounted inside the running container, inside its running container at the directory /data, and it should find that at the external volume, the external location on my local host at /root/shared project data, whatever I said. So let's look at so in blue, for those of you who aren't colorblind, blue are just the API words. Those are the API parameters. You'll see something called a volume mount. By the way, remember I said containers, you can have one or more containers. Notice that dash there. You can have one or more containers. So even if you only have one container, you have to specify it as an array. And in YAML, that's our list. This is how you specify that in YAML. So I'm saying in the first container, that's going to be in this pod, it's going to want some volume mounts at the directory /data inside the running container. And then there's a name my data volume. Took me the longest time to understand what they're saying. That is just a self-referential alias. That is just a self-referential alias to this YAML file. So we see down at the bottom a section called volumes, and notice you see it also has a name. That's how you bind those two. It's saying the volume that I'm mounting in this running container is defined in the volume section here under the same name, right? And in this example, I'm saying it is a host path volume, and it should be finding it, use that volume. So using /proj root/shared data/project data. Okay, so you see there's the indirection, but effectively I'm giving all the information needed for the kubelet to create the running container by doing the docker-v, the thing in purple, to /data. Okay. So again, under the covers, what's really going on is when a Docker container is started, remember I said about the overlay file system, and then there's this sort of the top read-write layer. So the overlay file system, as that's some ugly name inside of your machine, /var/containers /storage /blah blah blah /ugly long hex name, and that's chosen by your Docker runtime. Say that's going to be the root of my running container. All right, so let's just call that the container root. And if you want to, you can do some archaeology into your file system and try and find where that actually is stored. It's I believe it's under /var/containers but let's just call it container root. That's some path on your system that that is the runtime root. That's where the files that are going to be presented to your running container, where it will find its root. So in this example, what the kubelet does is the moral equivalent of docker run -v into the container root /data. So that's where I'm projecting it from the source, the target, from the source on my local machine, on my the regular path /root/data/project. That's all it's doing. No magic. So, Eduardo, if you're talking to me, I can't. You're muted. If you're talking to somebody else, that's fine. I'm just letting you know I see you talking and I don't hear it. All right, so it makes sense. No magic. That's all the kubeless doing. All right. The first area of confusion is there are all these Kubernetes objects, and the first thing you learn is something called the volume mount and the volume. These are not Kubernetes objects. These are not Kubernetes. These are just API parameters in the pod. Okay, they are not. There is no volume object in Kubernetes. There is no volume mount object in Kubernetes. Okay, and I also want to stress that the volume mounts, if you know how to read JSON notation for how, JSON search notations, the volume mounts are under the spec.container. Namely, there's volume mounts for each container. Remember, you can have more than one, but the volume definition is on the pod level. All right, the definition, the actual definitions of the external storage are on the pod level. So now that I've taught you how to do that, don't do that. Host paths are fraud. They're just fraud. There's a whole plethora of reasons why you wouldn't want to do that. Not the least of which is you're assuming something's going to be on the host path. And in most Kubernetes deployments, the nodes are locked down and you can't put files on the host anyway. So it works great when you're it's useful during dev. It can be useful during dev, but in production, it is just never supposed to be used. It's just, and it's a security breach. It's an absolute path, which means, by the way, you don't know which node your pod is going to run on, which means if you really want this to work, you have to have the copies of those files on every node in your Kubernetes cluster. So host path, maybe on your desktop during dev, but never in production. Okay, but it was a good example to see what's going on. All right. Next, problem number 2.